about the today's this session, what is going to be, and what you will get in this program. Just give me a moment. Aditya, are we live?
Yes, we are live.
All right. So I'm just quickly sharing my screen. Is it visible to you, Aditya?
No,
Can you
not
see
yet.
my screen? Okay.
Yes, sir. Visible.
Okay, now it's visible, I believe.
Yes,
right?
now it's visible.
Okay, let me put it into a full screen. Okay, so now this is for which we are gathered here. It's a master class on machine learning ops we are conducting. So we have with us Mr. Neeraj Kumar. So Neeraj is a thorough professional on, he has almost 2 decades of experience in project management, AWS systems, cloud solutions, in deployment part as well. And also he mentors the candidate at Aegis and also take care of certain subjects at Aegis also. So today it's a 1-hour session in which we'll give you a kind of overview on that machine learning ops, and there is a takeaway sessions for you, for those individuals who wish to make their career in core machine learning. And there is a specific course we are launching in the month of October. So for that part, we will be discussing once you get a complete overview that what that machine learning ops is all about. So we will know more about, we'll take a deeper dive into that this particular session for which we are gathered here today. And so the quick overview about this machine learning on AWS ops. So this course typically introduces the participants to different machine learning operation tools, which is and the best practices for deployment, you're evaluating, monitoring purpose, and the operational production for the machine learning systems on Google Cloud. So this particular, the machine learning ops is a discipline particularly, which is focused on the deployment part, the testing part of your different models, if you're using any ML modules or systems in particularly productions. And all these tools, which is particularly being required by all the top-notch machine learning experts, which we call them data scientists as well, they continuously using these tools for the improvement and the evaluation and the deployment purpose of your different models that the individuals they work upon. So this is a quick brief overview about the agent. So we will have the expert with us. So he will take you a deeper dive into that particular course for which we are gathered here for this master class. A quick brief about Aegis. You might have got some idea. Let's still give you a quick gist about that. So Aegis, we are primarily an institution. It's one of the autonomous institution in which we are offering programs in data science and machine learning and cybersecurity. And we are the Asia's only institute who offers master's program in data science, cybersecurity, and telecommunication. And we started our journey long back 2002 with the support of Bharti Airtel. And that was a time when telecom disruption was started happening in India. So almost 7 years back, we got into the engagement with IBM. You all must have heard of IBM, I believe. So IBM, they are the major leaders in, they are the leaders in that data science, AI, and cloud vertical. They join hands with us. And with IBM, we have established state-of-the-art analytics, data science, cybersecurity cloud labs, and we rolled out various master's programs that I quickly discussed with you. So we are a proud training, we are the proud official partner with this course, the GMAT, TOEFL, and GRE. So you can take a deeper dive by knowing about Data Science Congress, which is one of the state-of-the-art, one of the brilliant event and the world's one of the largest event in which we do invite all the CTOs, the CIOs, thought leaders. So this event you can get to you get more information about that if you go and check out on Google. Aegis Data Science, Aegis Graham Award. So we initiated that Aegis Graham Award, which is one of the largest innovation award in the entire globe. That award is known as Oscars in Innovation, in which we do reward the innovations which are coming up in different segments altogether. So it's a quick brief about us. And the secondary line of business at Aegis, we have a consulting wing under which we take a lot of projects, consulting assignments from the enterprises, the governments, and the top-notch institution, be it large scale or small scale. So this is the secondary vertical which we have. If you guys, any one of you, because I can see that still the candidates are joining in, if you would have any skills on machine learning or these disruptive technologies, what we call it, we are hiring as well. So this is A quick brief about us. So we are these are the industry and the academia collaborations we had over the past couple of years with the top-notch giants, with IBM, they joined hands with us. NVIDIA, they have also joined hands with us. UBTech, you might have heard of the UBTech name. They are one of the largest leader in robotics and computer vision. If you come to our institution, you will find with some robots, which would do a kind of humanoid to whom we are training on various skills. AWS, Amazon, they have also joined hands with us. With Amazon support, participants, they will get additional access on the entire AWS cloud labs. This is a quick brief about the academia side, what we are in. So these are the programs, what I have discussed with you. So this is a full-time program, as you can see. The things are getting normalized now. We are getting back to from new normal to normal. And this is a full-time program we are starting. We have already started 7 years back, as I told you. This is a postgraduate program in data science, business analytics, and big data we offer with IBM. And that program we are starting from 22nd of September this month. And similarly, if the candidates, they do not want to come on campus, we offer this program in a live interactive manner as well. We offer the very intensive program which is a postgraduate program in cybersecurity, which we offer with IBM. So similarly, two models are there, full-time as well as the live interactive mode of delivery. Full-time program, which is a 6 days a week. And there are executive models as well for the working professional, because I believe in that gathering what we have today with us. So there are candidates who have the working professional who wanted to do a transition, into data science or cybersecurity. So we have the executive models as well, which will be only on Saturday and Sunday. And all these models either on campus or live interactive. Do not believe in offering any recorded sessions. So all these sessions, what we offer, these are all live interactive sessions. So it's a quick brief about the programs. We also offer programs in postgraduate program in applied AI, machine learning, and deep learning. If anybody wanted to get an advanced level of data science, this is another program that we offer. So we are going to launch full stack development program in association with IBM. And also, rather taking much of your time and without any further ado, we are gathered here for this master class, which is a MLOps, for which we are gathered here today. I'll not take much of your time, but this is another course which we are launching. If you wanted to completely get your hands on machine learning ops, so we are the only institution who is coming up with that program, and we are starting this program from 20th of October. So for which today's session, for this 1 hour, I'm asking Neeraj to come forward, and I'm leaving this virtual dais to Neeraj right now. Neeraj, can you hear me?
Yeah, thanks, Ritin.
Okay, so over to you, Neeraj. I hope, guys, that it will be a very enlightening session for you. So over to you, Neeraj. Take care. Yeah, all right.
Yeah, thanks, Ritin, for giving this introduction of Aegis and what all we do. So first of all, very good evening to all of you. I can see that there are around 70 participants has already joined, and the rest will keep on joining, right? So before we start, let me just, am I audible to every one of you?
Yes, we can hear you, Neeraj.
Okay. And I would request all the participants, if you can also switch on your video so that I can see each of you if possible. Let me share my screen. All of you can see my screen?
Yes, we can see that.
Okay. Okay, so very good evening to all of you. Before we start, let me just give you my background also, so that it will help you guys to understand from where I am coming and what I am going to cover today. So myself, Neeraj Kumar, I have been in industry, as Ritin says, since last 2 decades, and have been in different kind of roles. I started my career as a software engineer, and then slowly moved towards the various role and work as a senior software engineer, tech lead, architect, senior program manager, delivery account. So all kind of aspects of software development and delivery I have seen in the organization. And primarily, I've been with IT companies as well as service sectors. So I've worked primarily on major banks, life insurance companies, and major giants in ITs like IBM, HP, Cognizant. I've been working as a software developer. Let me just adjust my camera so that you can. Okay, so let's start for today. So what we are going to cover today is basically these are the agenda that we will cover. One is the data scientists. What are the pain points that data scientists face? The concept of DevOps in ML, machine learning lifecycle, and then challenges that we face in scaling machine learning. Just give me a minute. Okay, so we will talk about. Am I audible to all of you guys? First of all.
Yes, yes, we can hear you, Neeraj, very well.
Okay.
Yes, sir.
So we will cover machine learning services, cluster management. So this is basically a technical part of this, and then we will cover specifically in AWS. We will cover how SageMaker and Kubeflow interact, and we will have a short demo. So before going into that, I just want to start with a very basic of what machine learning. So can any one of you let me know what basically, as per your understanding, you think of machine learning as? Any one of you? Hello? Am I audible?
We can hear you, Neeraj. Yes, very much.
But I'm not able to hear any participant voice.
No, that is fine. We can go ahead with that. So we
Okay.
can have a quick Q&A session at the end. So if the
Okay.
participants, they would have any question, they have the flexibility. So I'm also asking the candidates if you would have any questions in between. So feel free to ask your questions over chat box. Okay, and we will take your question. We will give our best to answer most of your questions. We are live on YouTube as well and Facebook as well. So you can ask your questions on these platforms also. So and the candidates, you have a liberty to ask your questions, and we'll have a separate Q&A session once we are done with that session. So Neeraj, you can please go ahead. Yes.
Okay. Okay. So let me define what basically it's a very well quoted thing. The learning is any process by which system improve performance from experience. So you guys have to understand two things, right? When we talk about machine learning, it consists of two words. The first is machine and other is the learning. So as the name says, it basically says that how your machine is learning and how machine is learning with the experience. So these three things are very important. Just keep in mind whenever we talk about machine learning, experience is very important. Also, as a human, like if you take a newborn baby, and if you just compare it with the machine learning, it's very close. Basically, the steps and what are required for a learning are very simple. So experience is one of the very critical part wherever the learning comes into picture. So we will see how learning plays an important role, right? Now the question is that why we want machine learning. So basically machine learning is used for wherever if you want to do any kind of develop system which can automatically adapt or customize themselves to individual users, discover new knowledge from the large database. This is basically data mining. If you want to get the insight from a data and then present it for the analysis or some kind of thing, then machine learning is also very helpful. And also at a very advanced stage, it will help you to mimic or replace the human capabilities, and especially when it is a very monotonous kind of task like recognizing handwriting characters, this kind of things, right? So these are the capability that you can get if you go into machine learning. Now the bigger question is because now we are now advanced, and we are talking about MLOps, which are pretty advanced concept, right? The question is that why now? Why we are talking about all those things? Why not we are talking about machine learning 10 years back or 20 years back, right? The major reason or major drivers is that there is a plethora of data, right? So the volume of data has increased. So there is a concept of big data. I'm sure that you all guys are aware of that. So right, so data has increased tremendously in last 10 years. The volume of data, the velocity of data, the veracity of data, all the three V's, which we talked about in the big data, right? In all these dimensions, data has increased. So that is one of the reasons why now machine learning is very, I can say, critical for software engineering or whatever you take it, right? Another thing is that computational power. Because of coming of the various cloud providers, now my infrastructures are easily available. With the click of buttons, you can get all kind of your infrastructures which is required for running your software or applications. So this is the second reason why machine learning is now becoming. These are the factors which is actually helping machine learning to actually come into practical life. One is the availability of the data, other is the computational power. Next thing is various kind of research that has happened in the recent past, and I can say was last 10 years, which gives you a various advanced algorithms which you can use to actually find the insight, or you can say that it can help you to actually develop your ML models, right? So these are the major three factors, and third one is the very important, that there is always required that you have a knowledge, you have a capacity, but unless until it is not acceptable by someone, it is of no use, right? So another important factor is that now industry also is able to recognize the power of machine learning, and they are quite open to actually experiment with capabilities or AI based models or applications which can be deployed on cloud and that can be integrated with their business applications. So these are the major four factors which are driving machine learning nowadays, and that's why we all are here right now. We all are talking about machine learning now. These are the major four important factors. What kind of application, ML applications we can develop? We can develop ML applications related to the image processing, vision, diagnosis, medicine, bioinformatics, gene expression, e-commerce, face recognition. You can think of anything. If you take it otherwise, I would say that all the kind of senses, like as human have, you have sense of vision, you have sense of speech, you have sense of touch, all kind of these senses now it can be implemented using machine learning capabilities. So you can think of capabilities of machine learning which is providing, right? So you have all senses now, and you can play with those senses, and you can develop any kind of application or gadget, whatever you want, and you can put in these senses or this capability inside those applications, and that's the beauty of having the machine learning, right? So and technology which is now being developed, you can integrate all these capabilities into your applications, business applications, and you can play with, right? So sky is the limit now, because now you can play with the senses, then you can do whatever you can think of. If you want to develop a chatbot, real-time chatbot, you can develop it, because now you have capacity of converting or playing with the voice, right? You can have a voice enabled chat box, you can have video and everything, whatever, right? So now I give you very general view of what is machine learning. If you take very academic view, or what I can say standardized view of what is ML system and what is learning, then learning is something improving with experience at some task. Let us say if you have some task T, and then you have to improve your efficiency of doing this task with some experience, then that is called as learning. Learning without experience is nothing. Whenever learning comes into picture, experience is always there. So you have to have some experience, and then only you can get those learning, and basis of that learning you can increase the performance of your task, doing the task. So that is the cycle of actually any learning. You have a task in hand and you have some experience, and as the time passes and your experience increases, then your performance of doing that task should keep on increasing. If your performance is not increasing, then your learning is zero. You are not learning, then you come to a saturation. So same concept applies to the machine learning. So you have any task, on that you get the experience. In terms of machine learning, when I say experience, it is nothing but it's a data. The data that you collect from various sources, basis that data you get the experience, or you get the insight, and basis as your data keep on increasing, your experience keep on increasing, and then your learning and performance of doing that task keep on increasing. That is in nutshell is the machine learning is, right? And that's why it's very important that you should have a sufficient and correct data. Both the things are important. In data science, you should have a correct data, as well as you should have good amount of data. The amount of data as well as the correctness of the data, both are required to have a right experience. Because if you have a data but that is a garbage, then your experience will be useless. You will not get any experience from garbage, right? So that's why the importance of data. Your data should be very rich, and it should be in volume as much as possible, right? So that your experience is rich, real, and then your performance will increase of doing the task will increase, right? So let's take one simple example. If you have something like spam filtering, this is your task, right? So identify the spam. The T is a task, that is you want to identify what all spam emails coming into your inbox, right? And then you have some experience that you have a database of email that were labeled by users. Then using this experience, having this task in your hand, you start learning, you start developing your algorithm with this experience, and then you keep on measuring the experience. As the data increase, as your emails increases, then your performance, the percentage of spam that were filtered, should keep on increasing. So your capacity of identifying the spam emails should keep on increasing. Let me just give me 1 minute. I lose the screen. Anyway, okay, so I was here. So before now, I just want to give you the background, or what are the phases of machine learning projects. Any project, if you do machine learning projects, you will have this kind of phases that you have to go through, right? So first is the discovery phase, then you have a development phase, and then you will have a deployment phase. So any machine learning project will consist of these three major phases. One is discovery phase, one is development phase, and one is deployment phase, right? So in discovery phase, basically you do define the use cases, you do the data exploration, you will select the algorithms, and then you prepare the data pipelines and feature engineering. So all these up to point number 1 to point number 4, these are basically a discovery phase where you do various kind of exploration. You do the exploration to understand your data. You do the exploration to understand what kind of feature engineering, what kind of algorithm to be applied or used to develop your model. So this is the discovery phase. Then once you are over with this, then you come into a development phase where you build the ML model, you evaluate your model performance, you present your result, and then once all these things are okay, you can see that all this starting from point 1 till point number 10. This is the iterative process. It's keep on going. It's not a straight line or waterfall kind of model where you start from stage 1 and then you do stage 2, 3, 4, 5, 6, 7 and it's done. No. The machine learning projects is an iterative process where each and everything has to keep on iterating unless until you find the result which are satisfactory. If your models are correct, you are getting the result as per your expectations, you have selected the right algorithms, you have data pipelines and features, everything in place, then only you can say that your discovery phase and development phase is over. So this one is iterative. Once that is done and you are happy with your results and it's meeting your business objectives, then you can deploy. And before deployment, you should plan for your deployment, what kind of infrastructure is required, what should be your release and deployment cycle, how your code will be managed, everything you have to plan in your before deployment. And then after that, you operationalize or you productionize your model. And once it is done, then you keep on monitoring your model also in production, how it is behaving, whether its performance is as per the expectations, as per the plan or not. Is there any fine tuning is required in your model? So you have to keep on monitoring the performance of your model. And if there is any improvement or area of improvement required, then you again start with the stage 1, and this cycle keeps on going, right? So as you can see that this cycle is a very complex cycle. Although in picture it looks very simple and straightforward, starting from point 1 and we can go to the point 10, but it required lot of collaborations, lot of tools, lot of expertise to actually develop a ML model and integrate it into a business applications and get the benefit out of it. So it's a very complex process. That's what I want to just highlight. The major point I want to highlight, this cycle is very complex and it's require a very niche skill set and right amount of infrastructure and tools to actually achieve this. And we will see this, what all feasible tools and techniques are available to actually achieve this. We will see this. Right now, you can see that any ML pipelines, when I talk about ML pipeline, this is what I talk about, right? So pipeline is nothing, basically it's about getting the raw data, doing the data extraction, then doing the data analysis, doing the data preparation, then you come to the model training, model evaluation, model validations, and then at the end you will get the trend model, right? And then you use this trend model to actually do the prediction services and performance monitoring, right? So as you can see, this cycle, all the left hand side, specifically the data processing or data preparation part, as well as your model training, evaluation, validations, are very small part of this cycle, right? This cycle is a master cycle, right? Which required everything. It required your discovery phase, development phase, deployment phase, everything. But in this, you can see the model training, model evaluation, and model validation. This is actually people understand when we talk about ML. But this is not only the ML. This is very small part of your complete life cycle. The complete life cycle is much more complex and much more bigger than this, right? So we'll see. So when we look into, so as an experience, when I worked in the industry and we involved in various kind of projects and all, right? So we hear a lot of time from data scientists what kind of pains and what kind of challenges or improvement actually you are looking for. So what we basically always hear from data scientists is that operationalizing a model means that balancing the time, resources, and quality throughout the whole system. So what basically I'm trying to say is that if you are a data scientist, you have developed your model, but to make it operationalized, to make it live in production and integrate with your business applications, you have to have a right amount of balance with the time, resources, and quality. So you have to manage, because any project cannot go for infinite time. It has to be well-defined time, scope, and resources, and you have to also meet the quality. So to tie up all these three parameters, your time parameters, kind of resources you required, and at the same time to maintain this quality, you need a very rigid, well-defined, standardized model to actually do it systematically with no error and have like highest possible quality when we do that, right? So from there the concept of actually MLOps comes, right? So ML, as you can see that ML system can easily build up your technical depth. When I'm saying technical depth, basically it talks about these 5 circles, right? Multiple functional teams. So because in any projects, the ML project or ML pipeline projects is not different from any project, right? You have multiple functional teams, you have various kind of experiments that you have to do. This is specific to the ML, right? So experimental nature is very unique in ML projects, right? So in ML projects, you have to develop the model, and then you have to keep experimenting with different kind of parameters. What we call in ML machine learning language, hyperparameter tuning, right? Different kind of parameters you have to set, which we say as hyperparameters, and you have to repeat your experiment till you find the right hyperparameter which gives you the correct output, right? So this is very unique to ML. This, right? It's experimental in nature. Then testing complexity, you have to test your model, right? So you have to have different kind of matrices, evaluation criteria of your model, where you can test your model and you see that what kind of matrices it's generating, whether my performance is correct, whether my number of epochs that is running is improving or not, whether we have different kind of matrices, right? And you run and test against that, what kind of matrices or performance parameters or data I am getting, right? If it is correct and testing is fine as per your expectation, then only you can go to the deployment. Now when you go to a deployment complexity, you have various kind of complexity. We'll talk about that, what kind of complexity we have in deployment, but this is also very complex and different from traditional machine learning deployment, right? So this deployment complexity, testing complexity, experimental in nature, and multiple functional teams, this is common. This multiple functional team you will find in any other project also. You have different functional departments, you take the requirement, gather the requirement, and basis that you have design specification and you develop and deploy it in a traditional non-machine learning kind of project, right? But this part, experimental nature, testing complexity, deployment complexity, and model decay, these are unique for machine learning projects. When I say model decay is that basically I try to say is that, let us say you develop a model and you deploy into a production. But after some time, what's happened, because your production is live, the kind of data that you are getting in the production from your end customer who are using your model is changing, right? And as the customer is changing, your data profile is also keep on changing. So kind of data you are getting in production and the basis of assumptions, the model you have developed will vary, will change as the time pass. So when the time passes, and then your model will not start working as expected. That is basically called as model decay. Your model is not performing as you are expecting, as it was developed. Because when you develop your model, you have certain assumption of your data. You think of data will be this way, this kind of the volume, this will be the nature of my data. But as the time pass, the nature of the data will change, the volume of data will change, the kind of speak, what I can say, kind of volume, right? You might have expect that 1 terabyte of data that you will be expecting, but you have launched some campaign and all of a sudden it has increased tremendous, right? So your model may not be able to consume that kind of data and give you the same kind of output, right? Because there are a lot of things, right? Whether your model is able to do parallel processing, whether your models are fine tuned, whether your backend infrastructure supported that or not. So all those complexity will come, and that will actually leads to the model decay, and you are not able to get the same kind of output from your models. And that's why this process is a backward. And that's why when I say deployment complexity, you cannot have a very fixed kind of infrastructure that you deploy on which you can deploy your model, because you don't know the kind of inflow you will get in your production. So your deployment infrastructure should also be a flexible. Your model should also be a flexible. And in the same time, your build part, like your experimental part and testing complexity, should be very standardized and well integrated. Otherwise, you will not able to meet the kind of scale that you will get in the production. And that's why it's very, very important that you should have very well defined infrastructure or technique or framework which can help you to actually support ML projects. And at the same time, you have to maintain the 3 constants that I talked about, right? Time, resources, and quality. These are very important. You cannot just deploy your model and you are not able to manage the time, resources, and quality of your model. Then it will of no use, right? And that's why the concept of MLOps and things comes, right? So let's take now I will move towards the MLOps, what basically is and how it actually help you out to address all these kind of challenges that you face, right? So MLOps is basically a life cycle management discipline for machine learning, right? So it's a machine learning operations, like we have DevOps, right? So before we actually go into the MLOps part of it, I just want to give you what basically DevOps, because MLOps is nothing, is come out of from the concept of the DevOps lifecycle and ecosystems only. So we customize the DevOps life cycles and ecosystem as per the requirement of ML. And what we get out of it, that is MLOps, right? So if you see any standard DevOps cycle, so it basically starts from planning, then it goes to the code where you have all your application codes. Then you build your application, or you can compile your codes. Then you test it, and then you release it into a different environment. You release it into a SIT environment where you do the system integration. Then you release into UAT environment where you just do the testing, and then finally you deploy it into a production. So after release, you go for a testing, and when testing is over, you come to a deployment. You deploy it into a production, and once you deploy, then you operate, then you manage that complete application in production. That is about operations. And at the same time, you have to keep on monitoring your application, how the performance is all. And based on your feedback, you again plan, you develop the code or re-engineer, refactor the code, build it, test it, release it, and deploy. So this cycle is a continuous cycle which keep on going, right? And if you see this picture or this diagram, for every phase, you have a very specialized kind of tools or framework which is available as an open source tools which can be used, right? Like for code, you have a Git for a code management, right? Where you can have a versioning and you can have like push and pull of your code, and you can maintain your code. It's a code repository. You have various kind of code management tools. Git is one of the famous thing, and one is the GitHub, right? GitHub is based on the Git framework only. Then you have a Jira where you have maintain all kinds of your dashboard, how your development projects are going on. You can publish your projects status and everything on Jira board, right? So that's more about managing the teams and communications. Similarly, for building, you have different kind of builders. We have Maven, which is used for basically may be used for Java applications to build your Java applications, compile and create the package jar file and all those things. Similarly, for testing, you have JUnit, Selenium, and then for the release management, you have a Jenkins, right? So you develop your Jenkins pipelines and you can release all your tested applications or code using Jenkins. You can deploy it into a different stages, be it a testing stage, or it's a UAT stage or a production stage. So all those orchestration can be done using Jenkins, right? Then you can go to the deployment. This part is very important, right? So when you deploy, how you want to deploy your codes, right? So there are two concepts basically. I just want to emphasize, right? Traditionally, we used to have very what I can say that standalone or silos kind of applications, right? Where like we have ERP systems or SAP applications, which are silos, monolithic in nature. When I say silos, monolithic in nature means it's use a fixed technology. Like if it is a Java based application, then everything is built in Java. If it is running on Linux operating system, then it has to run into a Linux operating system. If it has to work into I can say like Oracle database, then it has to work only with the Oracle database. So when I say monolithic, means that the complete application is completely tied up. All your components are completely tied up, and your platforms like operating systems, your databases, your servers, all are well defined, and within that well defined boundary or environment, your applications keeps on running. If any one of these things breaks, either your environment break, either there is a problem in the OS operating system, or there is a problem in your database, there is a problem in your compiler, anywhere, then you go for a toss. And in such scenario, when you have to debug and correct the issue, then it's a very risky, because first of all, it's a monolithic application, so it's a huge application, right? You need a very well known idea of your complete architecture of your application. You should know where to go and make changes, because of being a monolithic in nature, you have to be very sure like where you are making a changes, because if you make a change at a wrong place in monolithic kind of application, it will disturb the complete application and your application will go down, because everything is tightly coupled. All your layer, your application layer, your front end layer, your middle layer, your database layer, everything is tightly coupled. Anything if you do wrong in your application layer, your complete application will not work. Anything if you do mistake in your database, it will not work. Anything goes wrong in your operating system, your application will not work. So everything is tightly coupled. You have to have very well expertise in touching those kind of applications. Normally, all old applications, the applications which are running in mainframe or ERP or SAP kind of applications, that's why you have a SAP expert, you have a ERP expert who knows actually where to go and fix the things, right? So that kind of architecture has multiple problems, right? So first of all, you have to have a very niche skill set. You should have an expert of SAP or ERP, and then you should have an infrastructure boundary, right? You have to have the Linux expert. If your application is running on Linux, then you should have Linux expert. If it's running on DB2 or Oracle, then you should have that kind of. So it's a very focused team which work and on a specific domain, and they know how to fix it. And in that kind of environment, if a developer is making change, then you have to inform everyone, including your system admin, including your database admin, that today I am making a change and I am deploying it into a production. So everybody should be aware, because it's a monolithic, everything is connected. It may have a repercussion on database side. It may have a repercussion on your operating systems. It may have repercussion on your front end, right? So everybody has to be updated about that, and it takes time also to make such changes. So those are the problems of monolithic applications. To come out of those kind of issues, there is a concept of microservices comes, right? And microservices are very loosely coupled kind of unit, and you can develop microservices, each and every microservice. So each microservices is specific for a specific functionality. let us say if I want to do only for banking, let us say I have a banking application, and if I have to follow microservice architecture, then in a microservice architecture, I can develop a microservice only for a opening an account, or I can develop another microservice for a deposit. I will develop another microservice for withdrawal. So depends on your business functionality, you can have a independent microservices which are independent totally. This withdrawal microservice has nothing to do with the deposit microservices. When I say totally independent, means that the idea is that each microservices should have its own code base, should have its own database, should have its own operating system. The complete environment on which that microservices is running is independent. If anything goes wrong, then only that service is down. Your complete application will not down. So that is the concept of microservices, right? And to achieve those kind of concept or architecture, these things are heavily used. Dockers are heavily used for developing your microservices. And that's why I want to give you the concept why Docker. We will see, because Docker is very important even for MLOps, because in MLOps we heavily use Docker, right? Then you have a various kind of cloud environment where you can deploy your applications. Like you for AWS, you can deploy into AWS, you can deploy into Azure, you can deploy into Google GCP or any other cloud provider. So you can deploy it into a different cloud environment, right? Similarly, for the operation, so you have different kind of automation tools. Like for Kubernetes is basically a tool which is used for is a container orchestration tool. Kubernetes, it's an open source and it is used for orchestration of your Docker or containerized applications. Similarly, Ansible is an automation tool which is used for all kind of automation that you want to do in IT for configuration. Similarly, when you come to the monitoring, you have different kind of like Nagios, Datadog. These are the monitoring tools, right? Why I am saying that? Because it's very important, because if you want to achieve that concept of MLOps, which is basically about managing your complete life cycle seamlessly, continuously, and maintaining within the constraint of your time, resource, and quality, then you should have a very well-defined pipeline, and you should have all kind of tools which is required in different stages of your DevOps or MLOps, which is at the planning stage, at the coding stage, at the building stage, at the testing, release, deploy, operate, and monitoring, right? So you should be we should be able to use all this kind of tools. This is just a glimpse of tools. Don't take it otherwise like these are the only tools. I have just given the samples. There are thousands of tools available in the market, right? Open source tools that you can use for developing your MLOps or DevOps life cycles or ecosystem, right? Now as I discussed with you the DevOps and MLOps, let's discuss about how it is different. DevOps and MLOps is different. Like in DevOps, you test and validate the code and components, but in MLOps there is an extra thing that you have to do. You have to test and validate the data schema and models, right? That's the difference basically between what I'm trying to say, traditional DevOps and MLOps. Overall concept is same, but the nature of activity or the kind of environment where you are working in a normal traditional DevOps and MLOps are different. And these tables highlight this, right? The focus on single software package or services. Here we consider the whole system, the complete ML training pipeline. We will see what are these training pipelines shortly. And then we have to deploy the code and move to the next task, the constantly monitor. But here we have to not just one-time deployment in MLOps. You have to continuously monitor your model, retrain it, and serve the model. So this is the MLOps. Right hand side you can see MLOps, and DevOps side you can see what are the various stages in the DevOps and how it's differ. MLOps differ from the DevOps. Anyone has any questions? So before I jump to the next slide, I just want to find your view. Is it going? Are you able to understand where I'm trying to move slowly?
So anybody would have any questions? So please ask your questions. You can type your questions over chat. or you have a liberty to please turn on your microphone. You can ask your question. So we can go ahead, Neeraj. We can have a quick Q&A at the end.
Okay. Okay, so these are the agenda that I have covered in a very high level way, right? Now let's understand the level of automation. When we talked about MLOps or DevOps, it basically talks about the automation. Now we have to understand what is the maturity of your ML process, right? Are you at the level 0 or level 1 or level 2? When I say level 0, basically you simply build an isolated model and deploy it manually. When we talk about level 1, then you have some kind of automation for a training phase of your ML pipeline, right? You have some kind of automation for training. When we talk about level 2, then we have to automate the training, validation, and deployment. So complete life cycle, your training phase, your validation phase, and deployment phase, everything has to be automated, seamless, and continuous. And that's the concept of CI/CD, right? The continuous integration and continuous deployment. So ML ops or DevOps basically consist of various things of CI/CD pipeline. When I say CI/CD, in CI it's a continuous integration, and when I say CD, then it's a continuous deployment or continuous delivery, right? So in continuous integration, basically, if I go back one cycle, the left-hand side of this circle, if you see, the plan, code, build, and test, these are basically is a part of CI, continuous integration, right? So this part is a CI part, and then the right side of this, where deploy, operate, and monitor, is part of your CD part, which is complete continuous delivery or continuous deployment, right? And the release is in between your CD and CI. So release is a phase through which you join your CI pipeline with your CD pipeline, and that complete your complete cycle of CI/CD, DevOps, and MLOps. Right now, so far we have covered into a very generic view of what is MLOps and what all those things. Now I want to take you through a very high level of AWS, how that MLOps has been achieved, or what are the possibility and tools which are available to actually do the MLOps on AWS, right? So that's why I'm saying the scaling machine learning on Kubernetes and Kubeflow with Amazon SageMaker. I will talk about very shortly about what is Kubernetes and Kubeflow, and then I will talk about what is SageMaker. But I assume that all of you are at least aware of AWS. So AWS basically is a cloud provider which provide you all the services over the cloud. So it has multiple services that AWS provides, and in that service stack there is a ML stack where AWS provides various ML services, right? So SageMaker is one of them services which is provided by AWS especially for ML. So I will talk about that shortly, right? Now let's see about what are the challenges. So let's assume, let's just take now I'm slowly moving into a practical, and I will give you one demo also how to happen. Now let's take the example of what are the challenges with scaling the machine learning. Take one simple example. When you are single, you are not working in a team, you are a single person, and you are working with a single server or single machine, right? This environment is a very simple environment. You and to do all your activity, you need a compute resources, means you need a CPU or GPU, depends on your workload or kind of your requirement. You need some storage to store your data. You need some kind of source control, and you need some kind of ML framework. Assume that you are a ML developer or ML data scientist, and you are working single on a single machine. Even then, in this simple environment, you need these 4 points, right? You need a compute resources, you need a storage, you need a source control to control your or maintain the version of your code, and you need some kind of ML framework. When I say ML framework, you work into various kind of frameworks provided by ML, like scikit-learn, PyTorch, Keras, TensorFlow, some kind of XGBoost, all these are the frameworks, the tools or libraries, right? Like scikit-learn is a library or a framework, right? PyTorch is a tool which is provided for developing all your DL models, deep learning models, right? Similarly, you can have a Keras or TensorFlow, right? So all those, so some kind of framework you would be using as a ML data scientist to work on to develop your models. And that too, even for a single person, single machine environment, you have this kind of complexity. You need all these things, right? Now think of a scenario where you are a single person and then you have to scale your things. Means when I say scale, you have to scale your infrastructure, because now you have to deploy your models into a cluster which has a multiple virtual machines or physical machines on premise or cloud, whatever may be. But to scale it, you have to manage a cluster kind of environment where you have various kind of machines, running in parallel, right? How you can manage this as a single person without tool? You cannot do this, right? But you want to scale also, because that's a business need. You have to have a scalability in your models, right? So those are the challenges that you will face if you have to move from left hand side to right hand side in terms of scaling your infrastructure, managing your infrastructure, or managing your pipelines, right? So how to mitigate that? So this slide basically shows you how specifically the AWS provide you that kind of capability where you can scale and you can manage very large pipeline or workload also, right? So if you can see this, there are three layers. So one is a compute. So AWS provide you a fleet of computes, various kind of servers, whatever you can think of, starting from a one CPU to starting from CPU to TPU, whatever, all kind of compute resources will be provided by AWS in the form of EC2. EC2 is nothing, is elastic compute, elastic cloud compute, right? So that provides you virtual machines, and you can scale this. You can scale horizontal, or you can scale vertically, whatever you want. What as per your business requirement, you can scale it. This is one. Another thing is that you need some kind of management for your deployment, for scheduling, scaling, management of your containerized applications, because we are not going to develop a monolithic applications in ML. We are going to develop a containerized microservices. So for that, you need some kind of infrastructure or services, and those services are provided by, in AWS specifically, is provided by service called as ECS, which is Amazon Elastic Container Service, and another service is called Amazon Elastic Kubernetes Service. So Kubernetes, as I explained you, Kubernetes is a open source, right? And AWS adopted that Kubernetes and developed this service. So this service, EKS, which is Elastic Kubernetes Service, actually built on the top of Kubernetes, right? And ECS, which is a Elastic Container Service, is built on the top of the Docker, which is the container management, container management tool. Docker is also open source. Kubernetes is also open source. So AWS has taken the container concept from Docker and has taken the Kubernetes from the Kubernetes open source and developed these two services, which are very scalable and elastic in nature, right? And then the top level, I will come to the Kubeflow. At the top level, then you will have the Amazon SageMaker. So Amazon SageMaker is basically a platform as a service. So what platform as a service means? PaaS. So there are various kind of services provided by AWS. Something is called as IaaS, which is infra as a service. Something provided as like SaaS, which is software as a service, and something provided as a platform, which is called as PaaS, platform as a service. So SageMaker is nothing, is a platform for a machine learning services. So all kind of the platform means, as the name says. So as you can take the platform analogy as a railway platform. In a railway platform, you will get all kind of services. You will get your ticketing service. You will take your lodging service. You can take your catering service. All kind of services are provided on the railway platform, right? For a traveler. If traveler comes to a railway platform, whatever he needs, everything is provided there in the platform itself, right? So same way, the AWS has provided a platform for a ML, machine learning, which their name is as a SageMaker. So you can take that analogy. The SageMaker is nothing, is a kind of platform. So any traveler, in this case, any data scientist who come to this platform, he will get all kind of services which is required for developing your ML lifecycle or ML pipeline, which start from your training jobs, algorithms, optimization, deployment, and auto scaling. All these services which is required by a ML pipeline or ML project is provided over at the top of this platform, which on AWS, which is called as SageMaker, right? Now you have, so in this diagram you can say, right, as a ML concept, as I was discussing, right, you need all kind of tools, services, and continuity, and you have to also maintain time, resource, and quality, right? So that all those three ingredients, time, resource, and quality, can be achieved if you have this kind of tools and platform available. And that's what cloud providers like AWS or GCP or Azure providing, right? So I'm talking specific to AWS because my expertise, I have worked on AWS, so I can talk about in that. But I'm sure similar kind of activity are there for Google as well as for their Azure, right? So these cloud providers will provide you this kind of platforms. They provide this kind of management services tools, and they provide this kind of compute. So all these things at scale is provided by the cloud. Now, even though if you have all these kind of resources, everything in place, but one thing was missing, and that was that you need something to actually integrate all these services and develop a workflow, right? So to achieve any task, you have to have some workflow in which your tasks are integrated seamlessly, and then you can automate the complete task, right? So the Kubeflow is nothing. The Kubeflow is that this Kubeflow provide you a capability to develop a ML workflow. Using this Kubeflow, you can integrate all these services, and then you can develop a complete ecosystem, right? And then you have that image registry where you can have this kind of, where you can store all your containers, this image registry, right? So I will talk about these two now onwards. I will talk about only the first two parts, right? So Kubernetes for machine learning, that is for Kubernetes provide you the orchestration of your containers. Basis that you can deploy all your containers into EKS, which is the service provided by Amazon, right? But there is some problem, right? If you just use Kubernetes, and if you are the problem is that if you are an ML or data scientist, you don't know all this technology, right? You don't know what is Kubernetes, you don't know what is ML or what is ML file, what is JSON file. Those technology you are not aware of, right? And that's the problem with the Kubernetes. I cannot give just a Kubernetes platform to a data scientist and ask him to actually start working on Kubernetes and start deploying your ML models, right? It's not data scientist friendly. To achieve this or to make it a data scientist friendly, what has happened that Kubeflow has come, right? And Kubeflow gives you a complete framework where it integrates all your ML specific things. So Kubeflow basically is a toolkit that you use to actually develop your ML workflow, and it provides you all kind of ML tools, like starting from your Jupyter Notebook, TensorFlow, Spark, PyTorch, MXNet, model tracking, model deployment, hyperparameter. All those things are provided by Kubeflow as a framework, right? It's a complete toolkit which provides you all those capability, and it runs on the top of the Kubernetes services. So using Kubeflow, you develop the workflow, and then you deploy that workflow onto a Kubernetes services or a Kubernetes network. And then you can easily do the orchestration of your workflow or automation, right? So that's why it's written very clearly. Kubeflow relies on Kubernetes to manage your infrastructure. So Kubeflow basically is a toolkit is used underlying Kubernetes services to develop the MLOps or your workflow or pipeline, right? And SageMaker as a service provide you all kinds of services which you require to develop. I'm just rushing through because we don't have a time. Let's go to a demo where I will explain you. I will show you a simple demo to explain how exactly all these things get done, right? So just give me a minute, right? Everybody can see the screen? Hello.
Yes, we can see.
Yes, sir.
Okay. So I'm
Yes,
just
you audible.
planning, yeah. So I'm just planning to give you a simple demo how you can use AWS services, Kubeflow to actually do the complete develop a simple workflow ML pipeline, right? Just give me 5 minutes. Let me do some basic setup first. Everybody can see the screen?
Yes, it's visible. Neeraj.
Okay. So what basically I'm doing that it is a machine, Ubuntu machine that is running on the cloud in AWS, right? So you are seeing this screen. I just logged in into this machine and I'm just running one command. And basically this is one command which I am running to actually do the port forwarding so that I can open my Kubeflow dashboard on my local machine, and I will show you the dashboard of a Kubeflow, how it looks and how you can use the Kubeflow for doing the complete orchestration of your ML pipeline, right? Let me just run this first. So I have just run this command, and actually what it has done is that it has forwarded the complete Kubeflow which is running on this cloud machine to my local laptop. I can now open that Kubeflow dashboard on my local machine. So I'm just going to my local machine now, and here I have to run one more command actually to accept that request. I'm just running this. This white screen, what you are saying is that it is my local laptop. In my local laptop, this is not on my virtual machine. This one is my virtual machine. This is my Ubuntu machine which is running on AWS, on which I have installed or I have done the installation of Kubeflow as well as Kubernetes. I don't have a time to show you how to do the setup for Kubernetes and Kubeflow, so I have just giving you a demo. Assuming this is a virtual machine, and I have started my Kubeflow here, right? And now I have gone to my local machine and I am just running this command. Once I run this command, I am again go back to my Ubuntu machine, and now I can access the Kubeflow UI from here. The so let me just open that and then I will give you. So everybody can see this screen?
Yes, sir, visible.
Okay, so this is basically a Kubeflow dashboard where I can do the complete automation of any ML pipeline. So I will just give you one example. Let me just develop one pipeline. So you can see, right? I'm just creating one pipeline. I'm saying upload pipeline. I'm giving some name. Let us say, let me give demo MLOps. I've given this name. I've given some description. MLOps using Kubeflow and AWS SageMaker, right? I have to upload one file which I have already generated. I will just upload that file. So this is basically a MNIST data classification pipeline. I am just uploading this pipeline. I have uploaded that, and then I just click on create. You can see this, right? Everybody can see, right? Hello.
Yes, a visual.
Okay, so you can see that it is a definition of my workflow. This is basically a graphical representation of your complete workflow. So which is the processing job, then hyperparameter tuning, then training, then creating the model, then creating a batch job, which is a transformation, and there is a deployment. So everything will happen automatically by using this queue flow. This complete flow will be deployed and generated automatically, right? And you can see it's a graphical way, but if I click on YAML, you can see that this is the ML file which is generated out of it, right? And I don't expect you guys to understand. The objective is to just to show you how easy and how convincing is this, right? The underlying concept, how it is being working, and all those things that we will cover in detail, each and everything, when we start this course, right? As the Ritin was talking about, right? So we are planning to start a course from the mid of October. So right, so you will understand each and every concept behind this, how to develop this kind of workflow, ML pipeline workflow using Kubeflow and Amazon SageMaker, and you can deploy it into the production, right? So after this, I just clicking on create run, right? And you can see that some of the parameters are get auto populated, and I'm using some of the services. You can see this part, right? I'm using these services, SageMaker services of AWS. So I'm deploying this model or this graph on Kubeflow, which is running on the top of the EKS, which is a Kubernetes service of AWS. And then internally, it will deploy everything into the AWS SageMaker, and automatically. I will show you this, how it will happen. Let me just click on start. You can see this one demo MLOps pipeline has been created. Let me just click on this. You can see this, the jobs has started. You can see this, the processing job has started. Now slowly it will go and it will complete all the steps one by one. Just have a patience. See, hyperparameter tuning job is completed. Now training jobs is started. Training job is completed. Now model creation is happening. Now model creation has happened, and now it's generating the batch transformation. So basically it's a batch mode of getting the inferences from my deployed model. Now batch transformation is open and model is being deployed into the production, right? So you can see this, the complete flow. You can see the progress of your workflow, where my component is and how it is being deployed and it is happening. Apart from that, if you want to see the details, what has happened, you can see all kind of details. It's maintained all kind of logs. It's maintained all kind of ML data. Everything is maintained here, right? I will show you another run where I can show you. It's the same thing, right? I have already run this. So you can see, right? I at the processing job. So in this processing job, what kind of ML thing has happened? So you can see what all it has done. You can see that it is running a pipeline called MNIST classification pipeline. You can see that it has generated one container. So everything is very technical. I am not expecting you guys to understand all those things, but what it has basically done is that he has taken the processing code and it has put everything into a container, which is running on the Kubernetes. And basis that, it has generated output. You can see that kind of output. It has generated what this processing job has done, that he has taken the MNIST data and then it has generated from that MNIST data into trained data, test data, and validation data. So it has created a data for us, and that's what the processing job is. That in the ML pipeline, the first thing is that you have to get the data, and then you have to create the training set, test set, and validation set. So this is what this processing job is doing, and it is doing everything on the fly, on the cloud, on the Kubernetes container inside SageMaker in AWS. So you get the benefit of the scale, you get the benefit of your volume, everything, because AWS is auto scalable. It doesn't depend on kind of volume, whatever. Even if you want to have a terabyte of data, you want to, it will be able to scale automatically. You do not have to manage the infrastructure. You do not have to think about how that underlying infrastructure containers are get instantiated, containers are get created, how it is running, how my models are get processed into SageMakers or AWS, right? You have to just generate this graph, right? So it has generated this testing data and all those things, right? I will show you the same thing in AWS cloud. So before going into that, I just want to show you how it actually looks in, right? This everyone can see this page, right? Hello.
Yes, sir, visual.
Okay, so
Visual, sir.
this is AWS website, right? I am at the console of AWS. As I was talking in my presentation, right? So AWS has various kind of services. So all kind of services which are provided by AWS are categorized into different categories. So one of such category is the ML learning, machine learning, right? Machine learning is a stack under which you can find all kind of ML services which is provided by AWS. So one of that service you can see that is the Amazon SageMaker. Let me just go into that Amazon SageMaker. I will show you what has happened. And that's the beauty of Kubeflow and Amazon SageMaker, right? This is the console page of your Amazon SageMaker, right, within AWS. If I go to this tab, which is the processing, so you can see that it has submitted this job. When I run this on my laptop, this is in my local machine. I am running on this on my local machine, this graph, but this is happening in my SageMaker over the cloud. And you can see this, it has run this one processing job. And if you open that, you will find that what has happened. Everything, all details you can find. What kind of infrastructure it has created, I will show you that. Just give me a minute. See, you can see what has happened, how much time it has taken. Yeah, it has taken 27 minutes to actually do the processing time, right? I'm just showing you my previous, right? Because I have already run it. I'm just showing you. You can see that how much my processing step has taken, what is the status of that, what is the creation time, when it was last modified, and what kind of code I have run. If you see that I am running a PyTorch. So my processing job is basically developed on PyTorch framework, right? So that's why it has deployed my code, processing code, into a container. That's why you can see the processing image. Image is nothing, is a blueprint of your container, right? What kind of container? Everything reside in the image. All these things will be covered in the training when you join the courses. What is image? What is container? All those things. So what it has done? It has created a container and it run that PyTorch code into this container, right? And you can see what kind of machine this is. This is ML M5 2XL, right? This is the smallest possible machine in AWS, right? But I can take any kind of instances. I can take GPU based or CPU based or TPU based, depends on my workload or volume. I can take any type of machine also, right? And then you can see that all kinds of matrices of your processing, right? You can see all kind of now apart from that, you can also see after processing, if you come here, you can see there is a hyperparameter. So this is another job which does the hyperparameter tuning of your ML pipeline, right? So it's again created a hyperparameter jobs. If you see, if you come here and if you see hyperparameter tuning, if you see that it has run actually 6 jobs in parallel with different kind of parameters that you have provided. So it has run multiple jobs and which runs in parallel, and then it find what is the best possible parameters that should be taken, right? And that is done on the basis of tuning. You can see, I can show you some of the best jobs, right? You can see this. Out of that 6 hyperparameter jobs which run parallelly, it is saying that these are the best parameters that you can use. All these things are automated. So your parameter tuning is automated and it's giving you what are the parameters that you should use. It's saying that for it is a basically I have used k-means as an algorithm. So k-means algorithm, these are the hyperparameters. It says that how many nodes you need, what are the mini batch size, how many dimensions you need for your features, right? And what is the objective metrics, how I am measuring the performance of my training jobs, right? It is on the basis of MSD. MSD is nothing, is the mean square deviation. All those things will be covered in the ML course, right? So the guys who are aware of ML, who know that what is this MSD means, right? So this is hyperparameter. Then if you go to the inferences, you can see that it has created a endpoint. This is another service which is running now. It is live in my model is live. If you see that it is live in cloud, anybody can now use this model. You can see this. So that's the way actually it happens in Kubeflow. Everything is automated. Within a second, you have seen that, right? Within a second, your application has gone through different phases of your life cycle and is get deployed into the production. Literally now this model, this model of k-mean models is live in production. Anybody can use this model. I have to just deploy, I have to just give one API. And anybody can use this API and consume my model, right? That's simple, right? If you want to have pipeline, right? So I'm just coming back to my presentation. I've shown you the basic demo, how it can be done. So going back to this.
So we have a question as well, Neeraj, in between.
Yeah.
So we have Uttam. He's asking question. He's live on YouTube. He's asking.
Okay.
And he's asking that if I add SAP data in a model and real-time data or historian. So when we deploy this model in real time, so if we not map SAP data, will it work in real time also?
It will work, but I just want to show you one thing. See, if you see my pipelines, right? So if I understood correctly your question, you have to develop the pipelines, right? Once you develop your pipeline, let us say I have a processing job. So your data has to get processed as per your model requirement, right? So that is the processing that you need to do on your data. But what I am trying to show or say is that by using this kind of tools, you can develop one time your processing jobs and then you can automate. And after that, on real-time basis, once you ingest those data, it will automatically go into that workflow and all your processing will happen and it gets deployed into your model. And if your model is deployed, it can be you will get the inferences against your data. So the question is that whether you can do real time or not. Yes, you can do real time, but you have to integrate your model, the deployed model, with your pipeline so that your data get ingested and it's reach your model and you get the inference back. It's quite possible.
So I believe, Uttam, you get your answer. If you are still live, so please mention thumbs up, or if you want to extend some question or you want to ask anything else, please do ask your question. So we can continue, Neeraj, with this.
Yeah, so I'm now open for Q&A. Anybody has any question or anything, I'm open for that.
So guys, if you would have any questions, please feel free to ask your questions. You can type your questions. If you want to ask your question in real time, you have an ability. It's flexibility for you. You can ask your questions with the experts, so we will try to answer all of your questions. Or you can type your question over chat box. You can type your questions on YouTube as well. We are live on YouTube also.
So guys, what I want to say is that MLOps is basically a very huge field in itself. There are a lot of tools and technologies which are involved. And if you want to have expertise in MLOps, so you have to have the understanding of machine learning, and you have to have the understanding of the operation part of it. And for that, the course that we have designed basically is bring the best of both the worlds, the machine learning expertise as well as the operation side. So in the course, we are going to cover how you can develop your MLOps pipeline using an advanced tool, open source tool like Kubeflow, and you can deploy that pipeline on a very sophisticated environment on AWS cloud using a very high in technologies like Kubernetes, containers, and you can automate that process so that your pipeline of your ML, which is the of your getting the data, getting the training done, do the model evaluation, create the model, do the model evaluation, deploy your model, and then get various kind of monitoring of your models in the production in real-time basis. This complete life cycle, how it can be done, will be explained in details with all the technology behind as a part of the course. So you will be taking understanding from the basics of what is container, what is Kubernetes, what is AWS, various kind of services, what is Kubeflow, how to develop workflow, how to deploy it, what kind of tools and technology and frameworks is required. So you will get the hands-on and understanding of all those technologies. And those are, and if you take my words, like in the industry, if you are just a ML scientist, and if you are not aware of this kind of environment, then it's really that's what industry is looking for. Industry is looking for a ML data scientist who definitely know the data science part of it, but he should also be aware of the working environment, so that when the data scientists come out from your lab or you are come out from your courses, you should be aware of that kind of tools and ecosystem, so that you can easily start working from the day zero in that environment and start contributing into the project. Otherwise, what's happened, the industry is facing that I hire a data scientist and then I have to give 2 months or 3 months of training to have him the understanding of basic of what is cloud, what is Kubernetes, what is Flask, what is container, what is Kubeflow, what is MLOps pipeline. So it's a cost for them, right? And that's why in industry nowadays it's a very hot, right? You should know the ecosystem also, where you can use your ML, you can deploy your ML model into existing applications pipelines using MLOps concepts.
So I believe, Neeraj, there are no more questions from the candidates, but I'll just walk them through with the program that you have talked about. So when it is starting and how they can apply and go ahead with that. So if you could stop sharing a screen, I'll quickly share my screen and give a quick insights about the program to the candidates. Yeah. So let me quickly share my screen. Is it visible? Aditya, can you tell me?
Yes, it's visible.
Okay, visible, sir. Visual.
Great. So now let me full screen my presentation so that it will be much more visible to you. Okay. So this is the fast track course on MLOps that we have discussed. We are going to launch in the month of October. So what is there in this program? So it's a 30 hours course. So once in a week session would be there. Commencement date, it's a completely live interactive session, no more recordings. It's a completely live interactive sessions that we do provide to the candidates. We are starting this program from 20th of October 2021, next month. any individual, the working professional, the data science, ML enthusiasts, and the career aspirants, they can very much go ahead and apply for the program. Applications are very much open, guys. So if you are looking forward to take that fast track course on machine learning ops, apply today itself, because applications, as I mentioned, it's open. Let me quickly take you to that link. And before that, I'll be sharing that link with you over chat box so that, okay, where's the chat box? Okay, here I can see that. I'll quickly share that link. I believe all you can see that link, which I just shared with you. You can take the snapshot of your screen, or you can, it's very simple, municampus.com/course/MLOps. You can very much go and check that link, what it looks like. So let me quickly take you that screen itself. This is how the course looks like. You only need to register on this program. And you will also get to know about, we are starting, as I mentioned, from 20th of October. And this is how the course looks like. You can go and check it out about the various dimensions, what we are covering up in this program. So this is how the course page looks like. And this is about the course. Let me again get back to the same presentation. So, so applications are open, as I mentioned. You can very much go ahead and apply for the program. And moving on to the next slide. So we are coming up with another exciting session. Today you had discussed and you got to know some information about SageMaker, which Neeraj had beautifully explained to you. He must have used this in that session itself. So in coming weeks' time, we are coming up with another session, which is an introduction to Amazon SageMaker. And it's a completely master's class on SageMaker we are coming up with. So if you want to take part in these kind of sessions, we are always in almost quite often we keep coming up with these such masterclass workshops, meetups as well. So most of you are, you might have taken another sessions as well, which we have been doing for so long, over the couple of years, I would say. So do subscribe to that channel on our YouTube channel. You will get to know tons of learning material you will get on that particular channel. What we have got, it is called Aegis TV. You can search, subscribe yourself, and hit the bell icon. I do sound like one YouTuber, but this is for our own good, because a lot of time we are keep coming up with these exciting and very enriching sessions from the top-notch experts, what we have got with us. So anytime, on the fly, on the go, if you would have subscribed, you will get the notification whenever we will be live. So you should familiarize yourself with the datasciencegyan.com, which is a page what we have got on our Facebook. You can go and check out that page, subscribe to that. You can also a pre-information you will get about the sessions we are coming up with, and also you can register yourself, because seats are on first come first serve basis. We are open for the questions, guys, and if you would have any questions, I'm Ritin Joshi. You can reach out to me. You can jot down my number as well, my team's number. It's 9022137010. So we will certainly would like to help you and assist you if you would have any questions, or in terms of your career guidance as well. So open for the questions again, guys. If you would have any questions, as I can see, still we have still some enthusiasts still with us on this session on the Saturday evening, I would say. Anybody would have any questions, feel free to ask your questions, guys. You can type your questions again, though Neeraj would have already have given a very well explanation about the entire structure, about the course and the MLOps, the demonstration. But still, you would have any questions, feel free to ask us. You can raise your hand, or maybe you can turn on your microphone. Okay, you can ask your questions through YouTube as well. All right, so I believe we are done. There are no more questions I can see that participants would have. But if you would have any questions, guys, do feel free to reach out to us and ask your questions. You can connect us over LinkedIn as well. So thank you so much, Neeraj, for this wonderful session. And we will be expecting more such sessions in our near future as well. So thank you so much for sparing time. And thank you for this wonderful audience, what we have got. So all the very best, guys, for your future endeavors. And thank you, Neeraj, again, for sparing time with the candidates and with us on the Saturday evening. Thank you.